Hello everyone. This is Zahid Bashir. I'm a faculty member in Department of Commerce, University of Gujarat, and a PhD scholar in Halle College of Commerce. In previous two videos, I have discussed some basic detail about CBSEM and PLSM. CBSEM is basically a technique which focus on large sample size. If you have a data set with large sample size, and if your model is somewhat complex and you have some theoretical backing in your model, then you need to use CBSEM. It is a technique which is widely used in Amos software, which is the sister software for SPSS. While when we are using PLSM, we need to use we need to use a smaller sample size. When our sample size is comparatively smaller, and we need to predict the relationship between different variables or constructs, and we do not have any theoretical backing, or our theoretical model is evolving, still evolving. It means that theory is not developed into a final shape. So we need to use PLSM. The good news is that in PLS4, both options are provided. We can use CBSEM as well as PLSM in Smart PLS4 model. I would like to show you here. If, if we need to start Smart PLS4, in the previous version in Smart PLS3, this facility was not provided, but in Smart PLS4, it is provided. It has provided a facility that you can use PLSM and CBSEM. You can see in the top here, there is an option of PLSM and there is an option of CBSEM. It means if you have a developed theory for testing the relationship between different constructs, and if your sample size is large, you can use CBSEM, and this option is provided in Smart PLS4. But if you have a small sample size with you, and uh, the theory that you are going to test with the relationship, with the type of relationship that you are going to use, is still evolving. The theory is still evolving. It has not developed. You can use PLSM. You can use PLSM for prediction purpose also. So both of these options are provided in Smart PLS4. So that is a best thing with Smart PLS4, that we can use the core functions of Amos 2 here. The next thing is that is the difference I have discussed here. The next thing is the detail about covariance based SEM. What are the basic features of covariance based SEM, and what is the advantage if we are going to use covariance based SEM? Covariance based SEM is basically create a covariance matrix between observed variable. What do we mean by observed variable? Observed variables are basically indicators. These are the indicators which we use for measuring a statement. For example, I would like to show you a direct example of something that may clear your mind about. Uh, 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 you can say the indicators. For example, let me show you something. For example, this is a questionnaire, a kind of a questionnaire. Uh, in this case, I would like to measure financial knowledge. Now, what is financial knowledge? Financial knowledge cannot be directly measured. There is nothing to measure financial knowledge. But these are measured directly. These are the statements like FK1, FK2, FK3, and so on. These are the statements. In statistical language, or in case of structural equation modeling language, these statements are called observed variable, because they can be measured directly using these rating scales like 1, 2, 3, or 4 or 5. Whenever a respondent select any of these number, it is basically a measure which is provided for measuring this statement. So the statement provided as a part of the questionnaire are indicators, and in statistical language we call them observed variable. So the statements are observed variable statements, or you may say the indicators are observed variable. So the CBSEM technique create covariance matrix for observed variable. It means that whatever your statements are, the CBSEM techniques will create a covariance between FK1 and FK2, and between FK2 and FK3, and between FK1 and FK3, and so on. How many indicators you have, how many statements you have, how many observed variables you have, every variable, every observed variable will be co-variated using CVSAM. So CVSAM is based on covariance matrix of observed variable and assume that observed variables are continuous. So it assumes that your observed variable or your statements are continuous and normally distributed. It means whenever we are going to compute them, the values will become continuous. The values may not be categorical like 0 and 1. The values may not be something like discrete numbers. The values will become continuous. So when we basically measure the composite variable, on the basis of these statements, when I calculate the financial knowledge on the basis of mean, it will become the continuous variable. So whenever, let's suppose, I would like to calculate a composite variable. Let me show you how to compute a composite variable to make it come continuous. So so that you can understand it fully. So it will make your variable continuous. So let's suppose we have some data set and we need to open it, like for example this data set, but this has no value in it. We need to open some other data set file. Open data. Let me show you some other data set from here. One, yes, this one. All right, this is a data set where you can find observed variable like ST1, ST2, ST3, ST4, ST5, ST6. These are observed variable because these are directly measured. So in order to compute a composite variable and make them continuous, you need to calculate here, for example, SDT, to write here mean STP1, comma, STP2, comma, STP3, comma, STP4, comma, STP5, comma, STP6. You need to click OK, and it will compute a composite variable. Now you can see uh, the value of your composite variable here. It has become STP. So this has become your composite variable. You need to see the data view. and yes, this is STT. Now these values are continuous because whenever a discrete number comes with decimal points, it's become continuous. So the thing is that we assume that our variable should be continuous and it should be normally distributed. It is an assumption. Always remember when you have a data set with more than 30 observation, it becomes normally distributed. There are a lot of other methods that you can apply in order to estimate whether your data is normally distributed or not. So this is the basic thing that you need to understand. It is widely used when the focus is on testing complex theoretical model. I have stated this. Your latent constructs. And what do we mean by latent constructs? There is a difference between indicators and latent constructs. Financial knowledge is a latent construct, while these statements are indicators or observed variables. So your variable should be uh, calculatable. Your variable should be just a minute.
सर आपकी आवाज नहीं आ रही।
All right. The next thing that we need to understand, your latent constructs or your main variable should be well defined. It means their measures are available. And there should be multiple indicators also. CBSEM aims to estimate the strength and direction of relationship among latent variable and observed variable. So you are going to test the relationship between your main variable and your observed variable. So these are observed variable. They basically measure the latent variables. So you are going to test the relationship between your latent and observed variable in case of covariance based SEM. Next was partial least square method. It is an approach which is considered non-parametric approach. So whenever your data is non-parametric, it means that your data is not normally distributed. Your number of observation are might be less than 30, or your data has a small sample size. You can use some PLS SEM approach. It is often used when the focus is on prediction or when the theoretical model is not well established, making it more exploratory in nature. So you should use partial least square method when you have smaller sample size. These are some of the components of PLSM that you need to understand uh, before applying anything on PLSM technique. The first thing is latent variable. Latent variable means your main variable that you want to measure using structural equation modeling, while the observed variable is basically the statements or the indicators that are directly measured using the statements or using the Likert scales. So using observed variable, you basically measure the latent variable. So latent variables are not directly measured. They are measured using observed variable indirectly. So the first step is to measure observed variable, and the second step is to measure the latent variable. So next thing is the path model. The path model basically specify a theoretical model that hypothesizes relationship between latent variable and observed indicators. Next is the path coefficient. The coefficient you calculate from your path model is basically used as a path coefficient. It is a it is basically a beta coefficient which you find through the path model. Next is loading weight, which indicates basically a weight or a value which you find using the relationship between observed variable and latent variable. So whenever you draw some path through measurement model, you basically create some relationship between observed variable and latent variable. And that relationship between observed and latent variable indicates some values which are known as loading weights. So those loading weights ensure whether your observed variable are significantly measuring your latent variable or not. So this is important to understand. Then next thing is measurement model. Measurement model basically ensures the relationship between observed variable and latent variable. So whenever we are going to test the relationship between observed and latent variable, we can do it through measurement model because it indicates whether our observed variable significantly measure our latent variable or not. Then there is a structural model which basically indicates the regression relationship between latent variables. So whenever we relate one latent variable with another latent variable, we are discussing the structural model. It indicates the direct and indirect effect of one latent variable on another. Then we may have inner model and outer model for our indication. PLSM consists of two components: the inner model, which represent the structural relationship between latent variable, and outer model, which represent the relationship between observed variable and latent variable. So when you are relating observed variable with latent variable, it is outer model. And when you are relating the latent variable with each other, it means you are relating one latent variable with another latent variable. So it becomes the inner model. Then indicators loading, it is same thing like outer loadings we have discussed previously. Then residual variance, it indicates the variance of your error term. Then model fit indices, we have some of the indices available as a model fit in PLSM. Why to use PLS4 for SEM? There are a lot of benefits of using PLSM, PLS4 for considering SEM. It is suitable when your model is complex. When you have higher order model more than second order model, it is suitable to use PLS4 for SEM analysis. It is very flexible. You can compare the covariance based SEM with PLSM easily because it provides option for both of them. It allows for the inclusion of formative indicators, indicators that define a latent variable, as well as reflective indicators that are influenced by latent variable. This flexibility enables researcher to better capture the complexity of real world phenomena. This is the only feature which is lacking in Amos, because in case of Amos, you can create only indication model. You cannot create formative model there. You can only use reflective indicator model there in Amos. But in case of smart PLS, you can use formative as well as reflective indicators model. No strict distribution assumption, unlike covariance based SEM. PLSM does not require strict assumption about the distribution. So these are the features. Handling of small sample size. Amos cannot handle small sample size. If you have a sample size less than 30, Amos will not perform analysis, or it would provide some error. But if you have a smart PLS4, it will perform well with small sample size, making it particularly useful for research context where obtaining large sample may be challenging or impractical. In some cases, in some scenarios, you may not be able to capture a large sample or large amount of data from a large number of people or institutions or individuals. So it is convenient to use smart PLS4 when you have small sample size. Focus on prediction. PLSM basically focus on prediction. making it ideal for predictive modeling and exploring complex relationship between variables. It is particularly useful in fields such as marketing, where predictive modeling is common. Efficiency. PLSM typically requires fewer computational resources and faster to estimate compared to covariance-based SEM. In case of covariance, when the model is much complex, it might take a lot of time to analyze or to estimate the model. But in case of PLSM, you can estimate the model more efficiently, or you may estimate the model in a speed way to save your time. Then integration of measurement and structural model. You can integrate the estimation of measurement and structural model into a single analysis. You need not to perform measurement model and the structural model in differently. You can create a single model where you can perform the measurement as well as structural model. But this was not case in AMOS. In case of AMOS, you need to perform a separate estimation for measurement model and another separate estimation for structural model. Then robustness to multicollinearity. PLSM is robust to multicollinearity. It means if your data has multicollinearity issue, the PLSM will automatically make it corrected. So meaning it can handle situation where variables are highly correlated with each other. This is particularly advantageous in fields such as social sciences and psychology, where multicollinearity is common. So ease of use, PLSM is user-friendly software as compared to Amos, because it provides an environment which is very easy, which is very you can say user-friendly for the researcher or data analyst to done with. So I would like to show you some of the things using Smart PLS here. Let me open Smart PLS. Let's have our first project. I have a data set loaded into Smart PLS 4. I have let you know the procedure or the basic environment of Smart PLS 4, and how to basically load the data set into Smart PLS 4 and how to create the workspace. So let's create a first model, a first PLS model. So how can we create it? After loading a data set into Smart PLS, you need to create your model. So double click on model 1, and it will show you something like this. This screen is appeared, and you can see a lot of observed variable are here, like adopt 1, adopt 2, adopt 3, adopt 4, adopt 5. These are basically the observed variables. So we need to create a latent variable on the basis of these observed variables. So let's create a latent variable. So how can we create it? You just go to the blank area, and you need to confirm whether the select option is active. Then double click in the blank area, and you will find a name alpha here. You need to write the name of your first latent variable. Let's suppose I want to uh, measure first latent variable with adopt. So I need to write adopt as my first latent variable. Now you need to press enter from your keyboard like this. So this is my first latent variable. So how can I measure adopt using my indicator? So just press control button from your keyboard and click on adopt 1, 2, 3, and adopt 5. Now unpress your control button, and now drag these indicators towards your latent variable. So these are the indicators which are measuring adopt. So let's suppose I would like to run a CFA on this model. I cannot run the CFA. I need to create a correlation between constructs two. This is the relationship between observed variable and latent variable that we were discussing in our CBSEM. If you remember that we need to create a relationship. Yes, this one. The measurement model. The measurement model specify the relationship between observed variable and latent variable. So in our case, this is latent variable, which is adopt, and these are the observed variable. So we have created a relationship between observed and latent variable. So let's suppose we have another construct here. For example, anxiety. Anxiety is somewhat large. We need to use a smaller one. Let's suppose it's enjoy. Enjoy variable. So first of all, I need to double click in the blank area. I need to write here the name of my uh, latent variable enjoy, and then I need to select using control button one by one, 4, 5, 6, 7, and then I need to drag them towards enjoy. It will look like this. Now, I have created two latent variable here. Latent variable 1 is adopt and latent variable 2 is enjoy. And these are the observed variable of this latent variable enjoy. So uh, how can I do the CFA or confirmatory factor analysis based on these two constructs? So I need to click on connect this button, and I need to drag an arrow from adopt to enjoy. Now they has become blue. If you can notice, before connecting, their color was not blue. When the color becomes blue, it means they are ready for estimation. Now you can estimate them easily. Now go to the calculate button, select PLS SEM algorithm, and select OK to calculate. Now it is calculated, and you can see there are some values appearing over here, and there are some values also appearing over here. Uh, for I have discussed here indicators loading and also the loading weights. According to here at all, when we are going to discuss the here at all, according to here at all, these are the outer loading values you are seeing here as a part of CFA or confirmatory factor analysis. These values should be greater than 0.70. If these values are greater than 0.70, it means these observed variables are basically significantly measuring their latent variable. It means these five are basically and significantly measuring their latent variable, which is adopt. In the same way, you need to check that these values should be greater than 0.70. It means these observed variables are measuring their latent variable. So this is how you can done the basic CFA or confirmatory factor analysis. I hope you have learned this. So do you have any question, Ms. Sinha? Because time is going to end. If you have any question, you may ask. The next session will be on Monday for the same time. Please let me
No,
know.
sir, it is clear. बस ये है कि I don't have, software, so I'll practice when I'll install this, and I'll let you know कि it is working or not.
All right, all right. So let's meet on Monday again and have a safe weekend and good weekend for you. So thank you very much, Miss Hina, for attending this session. Thank you.
Thank you, sir.